Hi everyone, you're watching Chemistry with Cat. Today we are going to learn how to find the empirical formula using a combustion reaction. Let's go. The question says, a compound contains only carbon, hydrogen, and oxygen. When a sample of mass 1.60 grams is burned in excess oxygen, 2.20 grams of CO2 and 1.80 grams of H2O are produced. Find the empirical formula of the compound. So if you remember from my empirical formula and molecular formula lesson, empirical formula is the most simplified version. We can't actually find the molecular formula unless we have the molar mass of the molecule, which they could have given us, and then we would have to find the empirical and then the molecular as well. But this question is just empirical formula. So we have to find the most simple ratio of atoms in the molecule. All right, to begin this question, I've written out everything that the question tells us. We have a molecule here that has some amount of carbon, hydrogen, and oxygen, and a mass of 1.60 grams. It's reacted with excess oxygen, so I put my little excess here, which is my own short form for excess, and then I use LR for limiting reagent. And then we have 2.20 grams of carbon dioxide and 1.80 grams of H2O. So the first thing we can do with this information is find out how much carbon and how much hydrogen is produced and use that to find how much carbon and how much hydrogen we started with. Now, the first thing is these are in mass, and like most of our problems, we cannot do anything with mass. We have to find the moles. So I'm going to use the moles equals mass over molar mass equation. So moles is going to equal 2.20 grams divided by the molar mass of carbon dioxide, which I found to be 44.01 grams per mole. The grams will cancel out, and I'll be left with 0.05 mole. Now for the moles of H2O, we have 1.80 grams divided by the molar mass of H2O, which is 18 grams per mole. Grams will cancel out, and we have 0.1 mole. Now, because carbon is only in carbon dioxide, we can say that over here, the moles of carbon is going to be 0.05 moles. Now, the moles of hydrogen is a little trickier because we have 0.1 moles of water, but in water, there's 2 moles of hydrogen. So we have to multiply this by 2, 0.2 moles of hydrogen. So we also know that the moles of hydrogen equals 0.2 mole. Now we can use these numbers to find the mass in our molecule. I'm going to use my moles and molar mass equation, and in this one, the mass is equal to the moles times the molar mass. So my mass of carbon is going to equal the moles, 0.05 mole, times the molar mass of carbon, which is 12.01 grams per mole. Moles cancel out, and I have 0.601 grams. Now, my mass of hydrogen is going to be the moles of hydrogen, 0.2 mole, times the molar mass of hydrogen, which is pretty much 1 grams per mole, and that's going to be 0.2 grams. Now, I'm going to use these masses to find the mass of oxygen. The reason I couldn't use this to find oxygen is because it's in both molecules, and that makes it super complicated. So instead, I'll just find the mass of oxygen is going to equal the mass of this substance, which is 1.60 grams, minus the carbon, 0.601, and minus the hydrogen, 0.2. That equals 0.799 grams. So now the reason I did all of this was so that I could find the moles of oxygen, which I couldn't do unless I had the mass. So now we will use this to find the moles. So moles of oxygen equal mass over molar mass, which is 0.799 grams divided by the molar mass of oxygen, which is 16 grams per mole, and we get 0.05 mole. So now to figure out our ratio, we have carbon at 0.05, hydrogen at 0.2, and oxygen at 0.05. Now remember, with empirical formula, I cannot round this number. I have to multiply these numbers until I get whole numbers. And what I had to do was multiply by 20. So when I multiplied by 20, I got carbon to be 1, hydrogen to be 4, and oxygen to be 1. So that is the empirical formula of this molecule, CH4O. And that's it. There are a lot of steps, but remember, with mass, we always have to find moles. Then, because they gave us mass here, we had to go with mass to find oxygen. If they had given us the moles, we could have just skipped to this final step and subtracted to find the total moles, but we couldn't do that because we didn't know the formula to find moles. So we had to use the masses, then convert that to moles, and then find the empirical formula. If you enjoyed this lesson, please thumbs up this video and subscribe to my channel. You can also turn on your little notification bell so you will be the first to know when a new lesson drops. I'm here every day at 9 a.m. and I will see you tomorrow for a quick lesson on solubility.